Hello everyone, welcome to this next video on complex analysis. In this video we shall see question from GATE 2000 and this question is of 2 marks. The question says, if we are given this function f of z is equal to 1 minus e to the power minus z divided by z, then the point z is equal to 0. So at this point z is equal to 0, they are asking whether we have essential singularity, a pole of order 0, a pole of order 1 or a removable singularity. So basically a pole of order 0 means no pole at all, right? So let us have a look at its solution. So here the function f of z is given to be 1 minus e to the power minus z divided by z. So now obviously if you substitute z is equal to 0 into this function, that means if you take the limit of this function, z goes to 0. So it would be 1 minus e to the power minus 0 divided by 0. So it would be 1 minus 1 by 0. So ultimately it would be 0 by 0 form. So this form is not defined. So in order to take the limit of this function, what you have to do, you have to apply the L'Hopital's rule. So you basically differentiate the numerator and then differentiate the denominator. So when you differentiate this numerator, you will be having minus e to the power minus z and then the multiplied by minus 1. So it would be plus e to the power minus z, and in the denominator you would have simply 1. So now if you substitute z is equal to 0 into this, you will have the value as 1. So this value comes out to be finite number, right? And if you check the function by expanding the series, you know e to the power z is equal to the series 1 plus z square by 2 factorial plus z cube by 3 factorial and so on. So e to the power minus z, it would simply be 1 minus z plus z square by 2 factorial minus z cube by 3 factorial plus so on. So when we substitute this series into the given function, so our function would become 1 minus this series. So it would be 1 minus z plus z square by 2 factorial minus z cube by 3 factorial and so on, right? And we have divided by 1 by z. So you see this 1 and 1 cancels and we are left with, it would be 1, right? This minus and minus becomes plus and z divided by z is 1, and we have minus z upon 2 factorial plus z square divided by 3 factorial minus z power 3 by 4 factorial and so on. So you see we do not have any term containing z in the denominator. So that means we do not have any pole. This is one thing, we do not have any pole. By this we have seen by expanding this term e to the power minus z, whereas when you took the limit of this function, it comes to be a finite number. So in this case we conclude that this z which is present in the denominator, that behave as if it would have a pole at the point z is equal to 0, whereas when you expand this function into the series form, you do not see any pole within this expression. So from here we conclude that the given function has a removable singularity. So that is the definition for removable singularity. So here option D is the correct option. Well, that is it for this video. Thank you for watching.